Welcome. We are looking closely today at a vital technical area: how to effectively secure modern cloud infrastructure.
Indeed. This analysis, synthesized by artificial intelligence, focuses on the core lessons from Practical Cloud Security Second Edition by Chris Dotson.
Our objective is straightforward. We want to examine the essential architecture and defense practices that you, as a technical professional, should be focusing on right now.
And we plan to approach this discussion, well, slowly and methodically. Capturing the important details of this material is key.
Let's start where the book does, with the preface. It seems to set a very practical tone.
It does. The book presents itself as a direct guide, helping professionals implement the most important security controls quickly and correctly.
And who is it aimed at primarily?
It mentions two main groups, reflecting industry shifts: security people moving into the cloud, and also architects and developers finding security is now a big part of their role.
That makes sense. What about updates in the second edition?
Oh, there are significant updates. It covers zero trust principles, which are so important now. Also, things like quantum-resistant encryption algorithms are included.
Future-proofing, to some extent?
To some extent, yes. And passwordless tech, passkeys, privileged access management PAM, and the growing need for software bills of materials, SBOMs, for supply chain security.
So quite current. Does it touch on compliance as well?
It does. While the focus is security, it gives guidance for meeting standards like PCI DSS, HIPAA, and FedRAMP. Practical advice there, too.
Okay, that sets the stage well. Let's move into Chapter 1, Principles and Concepts, Foundational Ideas.
The first one discussed is least privilege. This is absolutely critical.
Explain that a bit more. What does it mean in practice?
It means you grant people or automated tools only the absolute minimum permissions they need to perform their specific job function, nothing extra.
So operate on a deny-by-default basis.
Precisely. Policies should deny access unless explicitly allowed. The book also points out a major risk related to this: the cloud management console itself.
Also,
By default, console access often comes with, well, near total control. Godlike privileges, as the text puts it. So controlling that initial access and subsequent permissions is vital.
got it. Tight control from the start. What's the next principle?
Defense in depth. This is the idea that any single security control can fail. A firewall rule, an access policy, anything.
So you need layers.
Exactly. Multiple overlapping layers of security. The failure of one control shouldn't lead to an unacceptable level of risk. It's about building resilience into your defenses.
That leads nicely into zero trust, another major concept.
Yes, and the book clarifies it should be seen as zero implicit trust. Trust isn't assumed. It must be earned and verified constantly.
How is that put into practice typically?
Common methods include encrypting and authenticating all connections, even internal ones, limiting user network access very strictly, and using multi-factor authentication, MFA, often with requirements for re-authentication for sensitive actions.
So it's a shift from just guarding the perimeter.
A fundamental shift. Protect every resource, verify every access attempt every time. The chapter also categorizes threat actors. Understanding who might attack helps design defenses.
Who are the main groups identified?
4 primary types: organized crime or independent criminals, usually after money; hacktivists looking to disrupt or embarrass; inside attackers may be seeking revenge or money; and state actors, often after secrets or causing major disruption.
Thinking about those different motivations helps tailor the defenses. Now, perhaps the most crucial cloud concept.
The cloud shared responsibility model. This is fundamental and often misunderstood.
It defines who is responsible for what between the cloud provider and the customer, correct?
Correct. And it varies significantly depending on the service model: IaaS, PaaS, or SaaS.
What's the key takeaway here, the part people get wrong?
The provider secures the underlying physical infrastructure, the data centers, the hardware, but securing access to your data, configuring services correctly, patching your operating systems and IS, that's almost always the customer's job.
And mistakes here have serious consequences.
Huge consequences. The book uses the example of open Amazon S3 buckets. So many breaches happen simply because this responsibility boundary wasn't understood or managed correctly.
A configuration issue, really, not a flaw in the cloud itself.
Precisely. It's an operational failure. The chapter finishes with risk management, defining risk as a combination of likelihood and impact.
And the strategies for dealing with identified risks.
4 main options. You can avoid the risk by stopping the activity. You can mitigate it, reducing its likelihood or impact. You can transfer it, perhaps using a provider's service or insurance. Or consciously, you can accept it if the cost of mitigation outweighs the potential impact.
That lays a solid groundwork. Principles, responsibilities, risk. Let's move on to protecting the actual assets, starting with Chapter 2, Data Asset Management and Protection.
The first step here is rigorous data classification. You have to know what data you have and how sensitive it is.
How is classification typically structured?
Usually based on potential harm. High or confidential data are crown jewels. Moderate or internal data where loss causes significant harm. And low or public data. This classification drives all other security decisions for that data.
And compliance requirements often dictate these classifications, don't they?
Absolutely. The book mentions GDPR for personal data, U.S. standards like FISMA FedRAMP using FIPS 199, ITAR requirements for U.S. personnel managing services, and PCI DSS for credit card data. These regulations heavily inform security design.
Okay, once data is classified, how do we protect it? The focus is encryption.
Heavily on encryption, yes, across its three states: data in motion, data in use, and data at rest. Data in motion is network traffic, covered later. Data at rest is storage encryption. Data in use is interesting.
Yes, the book mentions confidential computing. Using hardware like Intel SGX or AMD SEV, can you explain the significance of that for an architect?
Well, confidential computing creates a secure enclave within the processor itself. Think of it like a protected black box inside the CPU where calculations happen. The data stays encrypted even while being processed.
So even the cloud provider, with access to the host machine, can't see the data during computation.
That's the goal. It provides a much higher level of assurance, keeping data protected from the underlying infrastructure administrators. It shifts trust significantly.
That's powerful. What about protecting data at rest? Key management seems crucial.
It is. The standard best practice uses a two-tier key system. A key encryption key, or key encrypts or wraps the data encryption key, the DIGA. The DIG is what actually encrypts the data.
What's the advantage of that structure?
The big advantage is cryptographic erasure. If you need to securely delete large amounts of data quickly, you don't have to overwrite it all, which takes time. You just revoke the key EK in your key management service, the KMS.
And instantly, all data encrypted with DKK is protected by that key EK becomes garbage.
Exactly. It's incredibly fast and effective, a real benefit of cloud key management systems.
The book also mentions trade-offs with encryption layers: disk, platform, or application level. Application level offers the most security.
It generally does, because the data is encrypted by your application before it even hits the database or disk. You control the keys entirely.
But there's a downside.
A significant one: functionality. If data fields are encrypted at the application level, the underlying database often can't perform operations like searching, sorting, or indexing on those fields effectively. You might have to decrypt large amounts of data just to find what you need.
So maximum security can sometimes mean sacrificing usability, a classic trade-off. Let's move to Chapter 3, still on assets, but focused on cloud asset management and protection.
This covers the infrastructure assets themselves. Compute like VMs, containers, serverless functions, storage block, file, object, and network components, VPCs, CDNs, TLS certificates.
What specific risks does it highlight for VMs and containers?
For VMs, it acknowledges they run on shared physical hardware, raising risks like side-channel attacks, Spectre, Meltdown. Though mitigation is usually the provider's responsibility here. For containers, the bigger issue is the shared operating system kernel. It presents a larger attack surface compared to VMs with their own kernels. This makes strong segmentation between containers absolutely essential.
And it circles back to object storage security again.
It does, and rightly so. Access control for object storage, like S3 bucket policies, is purely the customer's responsibility. Misconfiguring these remains a leading cause of major data breaches. It cannot be stressed enough.
This relates to the overall asset management pipeline described.
Yes, the flow from procuring an asset through monitoring and scanning it with tooling to generating findings or alerts. The pipeline breaks if you have tooling leaks assets you don't even know about, so they aren't scanned.
Or findings leaks.
Exactly. Where vulnerabilities are found, but the findings are ignored or lost, and nothing gets fixed. This is where detailed tagging becomes crucial. Tagging assets, say dataclass.high, ensures your tools find them and your policies are applied correctly.
Tagging for inventory and policy. Makes sense. Now, let's shift focus to access control in Chapter 4, Identity and Access Management, IAM.
First, the book makes the crucial distinction between authentication, proving identity, asking who are you, and authorization, determining permissions, asking what are you allowed to do. Two separate but linked concepts.
And it talks about the identity lifecycle.
Yes, the sequence. Requesting access, approval, provisioning the access, the actual use of the access, and critically, revalidation, regularly checking if the access is still needed.
Why is revalidation, especially for offboarding, so important?
Automation here is key. When someone leaves, you must ensure all their access is revoked. This includes long-lived access tokens or API keys. If those aren't revoked automatically, they might still provide access even after the main account is disabled.
A potential backdoor. What about ensuring authentication is strong?
Strong authentication means MFA is essential, but also crucial is how passwords, if used, are stored. The book insists on modern, strong, slow hashing functions. SMIPT, bcrypt, Argon 2.
Why slow?
The slowness makes offline brute force attacks, like cracking dumped password hashes, or online password spraying attacks much, much harder and more expensive for attackers. It buys you significant time.
Okay. And what about machine identities? Secrets management?
Secrets are credentials for machines, API keys, system passwords. They need the same discipline as user credentials. Encrypted storage, frequent rotation, and stored in dedicated secrets managers like HashiCorp Vault or Azure Key Vault.
Good goal being.
To minimize the number of humans who ever actually see or know the secret value, automation should handle fetching and using secrets wherever possible.
Finally, for IAM, the authorization structure. Groups versus roles.
A group is just a collection of users or identities. A role is a collection of permissions. You typically assign users to groups and then assign roles, permissions, to those groups. The book strongly advocates for centralized authorization using cloud IAM roles for better visibility and control.
That clarity is important. This leads us to Chapter 5, Vulnerability Management. The big challenge here seems to be the speed of the cloud.
That's exactly it, the cloud rate of change. With CI/CD pipelines deploying code multiple times a day and the use of containers, the old monthly or quarterly patch cycle just doesn't work anymore. It's too slow.
So the process needs to be continuous.
Continuous and highly automated. Vulnerability management has to integrate directly into the development and deployment pipeline.
Where are the main vulnerable layers the book focuses on?
It looks across the stack. At the application layer, risks like broken access control and various injection attacks are always present, but a huge area of current risk is in dependencies, vulnerabilities, in third-party open source components. Think Log4j. That's a major focus now.
How do we find these vulnerabilities? What tooling types are needed?
A range of tools. Network vulnerability scanners give an external view. Agent-based or agentless scanners look inside VMs or hosts for OS and middleware patching and configuration issues.
And for the application code itself?
That requires DAST, Dynamic Application Security Testing, SAST, Static Application Security Testing, and crucially, SCA, Software Composition Analysis tools. SCA tools identify dependencies and known vulnerabilities within them and help generate those important SBOMs.
Beyond patching, there's configuration drift.
Yes, this is a huge source of vulnerability. Systems changing over time, deviating from their secure baseline configuration. Regular checks against hardening benchmarks, like CIS benchmarks, are essential. Rehardening images regularly helps too.
One last point from this chapter. A warning about penetration testing.
A necessary warning. Pen testing is vital, but you are testing within the provider's shared infrastructure. You absolutely must get explicit permission from your cloud provider before launching any penetration tests. Otherwise, you risk violating terms of service and getting your account suspended.
A crucial operational detail. Let's move to defense in depth at the network level. Chapter 6, Network Controls.
Building on earlier themes, zero trust networking is reinforced. The mandate is clear. All traffic, especially internal east-west traffic between your own services, must be authenticated and encrypted, typically using mutual TLS. Don't trust your internal network implicitly.
How is network segmentation achieved in the cloud?
Primarily using the provider's tools. Network access control lists, or NACLs, operate at the subnet level like traditional firewalls. Security groups operate at the instance or host level, a stateful firewall right on the VM or container endpoint. Layering these within VPCs restricts lateral movement for attackers.
And the encryption standard mentioned is Transport Layer Security, TLS.
Yes. TLS, ideally version 1.3, provides authentication of the server and, optionally, the client, confidentiality, encryption, and integrity, preventing tampering. The crucial part is enforcing certificate validation, even internally. Otherwise, man-in-the-middle attacks become possible within your own environment.
Are there more advanced defense tools discussed?
Yes. Web application firewalls, WFs, sit in front of web applications to filter malicious HTTP requests. Runtime application self-protection, RASP modules, integrate into the application itself to detect and block attacks in real time. And anti-DDoS services are important, tailored to your specific threat profile.
The chapter also highlights egress filtering, controlling outbound traffic. Why is that so important?
It's a critical layer. It can prevent malware that lands inside your network from calling home to its command control servers. It also severely hinders large-scale data exfiltration. Attackers try to sneak data out, sometimes using unusual protocols like DNS or ICMP. Strong egress filtering can block that.
Blocking the exit route. Okay, let's conclude with Chapter 7, detecting, responding to, and recovering from security incidents. Detection seems key.
Absolutely. The speed of detection directly impacts the cost and damage of a breach. The book notes that companies identifying breaches in under 200 days save significantly. Faster detection is paramount.
What frameworks help structure incident response?
Familiarity with established frameworks is recommended. The MITRE ATT&CK framework helps understand attacker techniques and tactics. The cyber kill chain provides a model for the stages of an attack, from reconnaissance to actions on objective.
What specifically should security teams be monitoring? What to monitor?
Key log sources include all privileged user activity console logins, API calls, alerts from all your security tools, WF, antivirus vulnerability scanners, and cloud service metrics, unexpected spikes in CPU, network traffic, unusual API calls. These can indicate compromise.
And a critical warning here too.
A very critical one. Never, ever log sensitive data. No passwords, no credit card numbers, no personal health information, no PII in your logs. This creates more risk than it solves.
How do teams manage all this log data?
That's the role of a SIEM security information and event manager. It aggregates logs, parses them, correlates events across different sources, and generates alerts. For effective response, you need enough hot storage in your SIEM to query recent data quickly during an investigation.
Preparation is vital before an incident happens. What does preparing for response involve?
It requires significant planning, defining the response team members and their roles, creating detailed incident response plans and practicing them. Crucially, maintaining separate, secure cloud accounts specifically for forensic analysis tools and storing evidence.
And budget.
Yes, having a pre-approved incident response budget is essential to avoid delays when immediate action is needed for containment or recovery services.
Finally, the recovery strategy. The book is quite definitive here for cloud environments.
It is. Given the nature of cloud infrastructure, the safest and most effective recovery method is almost always to wipe and redeploy all affected systems from known good, verified images or infrastructure as code templates.
Not trying to clean up infected systems.
Generally, no. Attempting in-place cleanup is risky. It's very difficult to be certain you've removed all traces of the attacker, backdoors, rootkits. The cloud allows for a rapid redeployment of clean infrastructure, which is usually faster and much safer. Burn it down and rebuild from a trusted source.
So to summarize the core message of this book, effective cloud security relies on deeply understanding shared responsibility, rigorously managing access and vulnerabilities continuously, and having well-practiced plans for rapid detection and clean recovery.
That covers the essentials. It's a continuous cycle, from identifying assets correctly all the way through to being able to redeploy cleanly and quickly. Discipline and automation are key.
This analysis has touched on the key technical and strategic points from Practical Cloud Security, 2nd edition. For the full details and operational guidance, we strongly recommend you read the book itself. It provides the depth needed to truly secure your cloud environments.
Indeed, the practical steps and configurations are invaluable.
Before we wrap up, here's a thought to consider. If the gold standard for recovery is to wipe and redeploy from known good states, how confident are you right now in your ability to do that? Is your infrastructure truly immutable? Are your backups verified? Are your deployment pipelines ready to rebuild everything cleanly and quickly under pressure?
A critical question for every organization using the cloud.
We hope this discussion has been valuable. We wish you a great day, and we encourage all friends of the show to subscribe for more analysis of critical topics like this one.